In this video, you will learn the basic and extended quantification of place values of a decimal system, the tricks of shifting decimal point, and how to write in standard form. The basic and extended quantifications are expressed as powers of 10 as follows: unit, tens, tenth, hundred, hundredth, thousand, thousandth, million, millionth, billion, billionth, trillion, trillionth, quadrillion, quadrillionth, 10 million, tenth millionth, 100 million, hundredth millionth, and so forth. Let us consider a decimal number u written in the form h times 10 raised to power m. M indicates how many places in u the decimal point should be moved to the right or left, or the number of digits jumped by the decimal point left or right. If u is a decimal number with digits d1 to dn plus r, m is positive when the decimal point is moved to the left. See, the decimal point moves 2 places to the left and m increases. As m increases, h decreases. M is negative when the decimal point is moved to the right. See, the decimal point moves 2 places to the right and m decreases. As m decreases, h increases. Let us try this. Move the decimal point of 100.01301. 1. 4 places to the right, 2. 4 places to the left. The decimal point will jump digits 0, 1, 3 and 0 to the right. So, from the starting place, m equals 0, we shift the decimal point 4 places to the right. Now, see the movement of the decimal point, and its effect on h. You will observe that h increases from 100 to 1,130,000, as the decimal point moves 4 places to the right. Keep in mind that the decimal point moves the same number of places as the number of digits. Here, there are only 3 digits to the left which are not enough. So, we place 0 before 1. The decimal point will move past the digits 0, 0, 1, and 0 to the left. So, shifting the decimal point 4 places to the left, from the starting place m equals 0, we have. Notice that h decreases from 100 to 0.01, as the decimal point moves 4 places to the left. Expressing a scientific notation, h times 10 to the power of p in standard decimal. P indicates how many places in h the decimal point should be moved to the right or left. For p equals positive integer, p decreases by moving the decimal point to the right. P increases by moving the decimal point to the left. P equals 0 when h is a standard decimal. In other words, m equals minus p. For p equals negative integer, p increases by moving the decimal point to the left. P decreases by moving the decimal point to the right. P equals 0 when h is a standard decimal. In other words, m equals p. Multiply 200.501301 by 1. 10 to the power of 5. 2. 10 to the power of minus 7. Since p is positive, the decimal point is moved 5 places to the right, through digit 5, 0, 1, 3, and 0. With the corresponding value of m equals minus 1, minus 2, minus 3, minus 4 and minus 5.
Notice that p decreases by 1, as the decimal point shifts 5 places to the right.
Thus, the value is 20,050,130.1. Here, p equals minus 7. This indicates that the decimal point will shift 7 places to the left for m equals 1 to 7. But the digits are not enough. We place 4 zeros before 2 to make up for the 7 digits. The decimal point can then be moved before the 7th digit. So, we have 0.000020050130 times 10 to the power of 0. Or 0.000020050130. Write 0.00356 times 10 cubed in the form b times 10 to the power of r. For the given value of r, 1, 0, 2, minus 5, 3, 6. First of all, write 0.00356 times 10 cubed in standard decimal. Thus, for r equals 0, we shift the decimal point 3 places to the right. The standard decimal is therefore 0003.56 times 10 to the power of 0. Or 3.56. For r equals minus 5, we move the decimal point 5 places to the right. Place 3 zeros after 6 to make up for the 5 places. Therefore, we move the decimal point 5 places to the right. Therefore, we have 356,000 times 10 to the power of minus 5. For r equals 6, we move the decimal point 6 places to the left. To make up for the 6 places, we place 5 zeros before 3. We then move the decimal point 6 places to the left. Therefore, we have 0.00000356 times 10 to the power of 6. Given the decimal number u, the standard form of u is given by d1.d2 times 10 raised to power m, where digit d1 is an integer from 1 to 9. Rules for writing a decimal number in standard form. Only one digit is allowed before the decimal point. The value of the digit can be an integer from 1 to 9. Write this number in standard form. 1. 10 million. 2. 0.000578. 3. 6111.07 times 10 to the power of minus 6. The invisible decimal point is at the end of a whole number. There are 8 digits before the decimal point, but the rule says only one digit is allowed. But the rule says only one digit, from 1 to 9, is allowed before the decimal point. So, the decimal point is moved 7 places to the left. Strike out long zeros after decimal point, and the result is 10 to the power of 7. There's only one digit before the decimal point, but 0 is not allowed. The digits can only be an integer from 1 to 9. So, we move the decimal point 4 places to the right. We have 0.000578 times 10 to the power of minus 4. And by striking out the zeros, the result is otherwise 5.78 times 10 to the power of minus 4. Only one digit is allowed before the decimal point. Thus, the decimal point is shifted 3 places to the left. Therefore, the result is 6.11107 times 10 to the power of minus 3.